Hey, what's up? It's your old pal, Mr. Cook. We're going to work on, let's work on the next two, okay? Let's see what we can do with these ones. Okay, so we're working on the Unit 3 review number 1 for the test. We got to determine which of the following is true. So it could be one of them, it could be all of them, it could be two of them, or maybe it's none of them. Like, let's determine what's going on with all this stuff. So let's take a look at the graph. Okay, so it looks like we're looking at different points. So what we're going to do is figure out, I guess, just an order of which one is greater than for all of these. So let's kind of see what's going on. And typically, what happens with these with these comparisons is the following: since you don't have a function, you can't actually find the derivative for certain points, or you can't find an actual value for some points. Like this one, for example. If I want to know what that coordinate is, I don't really know what it is, but I got to kind of guess what it is. So can you kind of guess what's going to happen if, like, say, if this is at x is equal to 1, what f of 1 would be? Well, you can't really know for certain. I mean, maybe this is -5, or maybe it's -10 or something. The only thing that you can be certain of, because maybe it's -0.23 or something, right? The only thing that you can be certain of, though, is that this coordinate right here is below the x-axis. So that means that it has to be less than 0. In other words, it's for sure going to be some negative number. Okay, we don't know what that negative number is, but we know it's a negative number. Okay, that's how you kind of need to work through a problem like this. Just, you don't know exactly what it is, but you have a hint of what it could be. Could it be positive? Could it be negative? Could it be 0? There are a couple points that we know could be 0, like that one and that one and that one, right? But other than that, we got to kind of guess. So let's look at this first inequality and see if it could be true. So we're going to look at f of 1. We're going to look at f of -1. And we're going to look at f prime of -1. Well, okay, let's start with f of 1. Well, we just kind of talked about that one. F of 1 is exactly that coordinate. I don't know what the y value is going to be at that coordinate, but I do know that it's going to be negative. Okay, so that might be good enough. Let's find out. So then if I look at f of -1, that's up here. Hey, I know that's positive. Okay, so I know it's a positive number. And so far, this inequality is correct because a negative number is, sure enough, less than a positive number, like 100% of the time, right? But let's see what happens at f prime of -1. Well, oh man, look at that. At f prime of -1, that'd be like the derivative at that point. It looks like it's going from increasing to decreasing. And when we change from increasing to decreasing, by the mean value theorem, this has to go through, a 0. Or actually, I guess, mean value theorem would be the one that shows that. Or I guess more specifically, Rolle's theorem would show that has to be a 0 value right there. Because if it goes from a positive derivative to a negative derivative, it has to pass through 0. So this derivative at -1 should be 0. So let's see if the inequality is still true. Is any positive number, whatever it is, going to be less than 0? Of course not. So this is not true. Okay, that's the approach that we're going to take for the rest of these problems. We're just going to kind of compare them and see if it's possible to create this inequality for this stuff. Let's try another one to see what it looks like. All right, so we've got f of -1, we've got f prime of 0, and we've got f of 1. All right, well, I know that f of 1 is a negative number. And then I just did f of -1, which is a positive number. This is already impossible, isn't it? Because I don't care what this number is. It's not possible for a negative number to be greater than a positive number. So this is already automatically false. Okay, so I don't even need to care what happens at f of 0. It just so happens that f of 0, like right over here, it looks like it's f prime of 0, I'm sorry. It looks like it's going down and to the right, so it'd be decreasing. So this would be a negative number as well. So I could stop this several times over and say that this inequality does not hold, because there's no positive number that I know of that's going to be less than a negative number, let alone two negative numbers. Okay, so that one's not true. So C's got to be it, right? So let's verify that that's the case because it's multiple choice. And it says which of the following is true. So none of them could technically be true. But let's see if this is the case. So f of 1, and then f prime of -1. And f of -1. So f of 1 was down here. It was some negative number. I don't know what it is. Just some negative number. F of -1, that was a positive number, if I remember correctly. Yeah, it's up there above the x-axis, so positive. and f prime of -1. Well, I calculated f prime of -1 earlier. That was 0. So let's see if this inequality holds. Is a negative number less than 0? Yeah, that's good so far. And then is 0 less than any positive number? It is. It always is. So that means that this is the one that has to be true. C has to be true. Okay, so now let's take a look at number 4. So number 4 says, let f be a differentiable function such that f of -1 is equal to -3. Awesome, we've got an actual coordinate for this graph. So if I graph it out, I go over to -1 and then I go down 3. I've got a coordinate for this graph f on the x and f of x function axis. Next, it says that f prime of x, so the derivative of x, and this is like awful. It's less than or equal to 3. So it doesn't even tell me what the derivative is. It doesn't give me a function for the derivative. It gives me a range of values, but the biggest possible value that it could have for the derivative is 3. 3 is the largest value that it's going to be. The derivative is going to be everything below that or equal to 3 at the most. For all x, it says. Which of the following is not a possible value for f of 4? So let's think about this for a second. All right, so what's not possible for f of 4? Well, the biggest derivative that we could possibly get is 3, right? So why don't we just ride with that? Let's just if it's a range of values and we're trying to find out what values aren't possible, we can at least get an idea of what the biggest possible derivative is at all times if we allow f prime of x to be equal to 3. Let's just assume that that's the best case scenario, biggest possible increases of 3, okay? And if that's the case, if it's just a constant value, for a derivative, you guys worked with derivatives earlier, then you can make a function out of this thing, right? A linear, this is going to be linear because if I do the opposite route of this, right? I would have a function of 3x, a slope of 3. So if I start at this coordinate and if I have a slope of 3 at the biggest for all x values, then if it's constant, the slope is always going to be 3. If the slope is 3, that means it's going to go up 3 and to the right by 1 from every coordinate. So that's what I'm going to do. I'm going to start over here. I'm going to go up 3 over 1. So that puts me over here at the origin. And then up 3 more. 1, 2, 3, and over 1. That's over here. So it looks like I've got this line that forms. And this is if I have the largest possible slope. So that means that the x value, and this is where you can kind of extrapolate some information or kind of make some conjecture or make assumptions a little bit later on, that any coordinate that I have, for any derivative less than 3 has to be below this. So that means that all the possible coordinates that I could have to be underneath that line for all x. Okay? So now let's try and work through the rest of this and solve this problem, because then it says which of the following is not a possible value for f of 4. Okay, so you know what? I'm just going to graph these coordinates out and see if they could fall in this little range of values that I have here. Okay, so f of 4, could it be equal to 2? In other words, could the coordinate 4, 2 be a possibility? Let's find out. Okay, so here's 1, 2, 3, 4. And yeah, 2 is right there. So yeah, this coordinate could fall in this range. So this could be a possibility. What about -2? So could f of 4 be equal to -2? Well, that means that the coordinate 4, -2 would have to exist. And if I went over 4 and then down 2, yeah, that's in the shaded region as well. So that's all right. What about 6? Could f of 4 be equal to 6? Well, that means that the coordinate 4, 6 would have to exist. Let's see if that works out. So that's 4. 1, 2, 3, 4, 5, 6, right there. Yeah, I guess that could work out. Okay. Yeah, so this one works out okay. It looks like it's in that range, like that region so far that I have graphed. Could 12 work? So could f of 4 be equal to 12? Oh, let's kind of think about this for a second. So it's kind of pushing it because f of 12 might be right around here. Wait, actually, now that I think about it, it's going to be exactly on that line, isn't it? Because, all right, if this coordinate here where we started was at -1, -3, if I use my slope and for the next coordinate, I went up 1, up 4 over 1, okay, that coordinate would be 0, 0. So it looks like for every 1 that I'm increasing in x, I'm increasing by 3 for the y. So the next coordinate over would be at 1, 3. and then it'd be 2 comma 6, and then it'd be at 3 comma 9. And then if I added 3 onto the next one, yeah, look at that. It's 4 comma 12. So it looks like 412 is like the biggest possible y value that it could be at 4. So anything beyond that is impossible. And that's why E is the one that is not possible for this. Okay, it's because the biggest possible value that you could have for 4 would be when the derivative is always, or the rate of change, the slope is always 3, right? Because that's the biggest, most optimistic value that we can get for y given some x value. Okay, so that's why number 4 works out that way. That's why E can. That's why the value of f of 4 can never be 13. Okay, that's it for this video and the first page of the worksheet. So we'll continue on with the next ones in the next couple videos. Okay, hope you enjoyed this video. See you in the next one. Bye-bye.